Hey guys, so this is your trainer Anirudh Chhillar. So we are back with one more video of OSPF. I hope you are learning in a good way and a good pace. So let's go for the next video.
Cool. Now you can move on R5 and you can see all routers are coming. Routes are coming from area 0, but as a inter area route. As inter area routes are coming, all routes are coming from different area. From area 0 into area 1 as a inter area prefixes, right? So all of them are present here as inter area IA. And you understand very well that what is the meaning by IA. Understood or not? So IA means inter area, means they are coming from different areas now. Now if you check its database table, because I said that routes will always come in the form of summary LSS, and summary LSS will be generated by ABR only. Understood or not? So these summary LSS have been generated by ABR only, and I said, actually I taught you before that okay, summary LSS would be generated by ABR only. So right now 3 is working as an ABR, and we have seen it. Even you can run this command as well. So I2SP border router that R3 333 is working as an ABR, and this is the cost to reach this ABR. Now try to understand the whole process going or performing behind OSPF. R3 is that router which is having or which is participating in area 0 as well as
area 1.
Fine. So it means R3 will be having router LSAs of area 0 as well as
Area 1.
how many routers are there in area 0?
3 routers.
How many router LSAs will be present?
3.
How many routers are there in area 1?
2.
It means Balaji. So 3 router LSS will be available in area 1 itself, and R3 will be having all 3 router LSS of area 0 as well as of area
1.
Let me show you. This is the database of area 0. How many router LSS are there?
3.
This is the database of area 1. How many router LSS are there for area 1?
3.
Now, ABR is also responsible to break. I will not say to break router LSA. I will say, let's say that it is having the database of area 0. It will run SPF algorithm. It will install best route inside its routing table, and for those best routes only, it will create summary LSS. Are you getting my point or not? So first of all, let's say that it is having the database of area 0. On that database, it will run SPF algorithm, will install best routes inside its own routing table, and for all those routes which are available inside its own routing table, it will be responsible to generate summary LSAs. Fine. So for the router LSAs of area 0, it will generate summary LSAs for area 1. See, because the loopback of R1, the loopback of R2, the loopback of R3, they were participating in area 0, and the 12th network in between R1 and R2 and 23's network between R2 and R3, they were participating in area 0. And this R3 is receiving that information in form of router LSS, but also it have broken them into summary LSS. It have also generated summary LSS. Now you must remember the path selection process of OSPF. Path selection procedure of OSPF. Like, first of all, intra area, then inter area. Intra area will always be preferred over. Are you getting my point or not? intra area will always be preferred over inter area. Done. So this time it is also possible that you are receiving same prefixes as intra area as well as inter area, but OSPF will always prefer, like here R3 is having, however it would be like kind of laughing if I am saying this statement, if I am giving you this statement, but just try to understand that in the database of R3 it is having the loopback of R1 in form of router LSA, and also it is having some RLSs for it. However, that some RLS is generated by itself. But again, it is preferring, like in the routing table of R3, you will get this one as intra area. And this time you can see that this ABR, this R3 is not having any prefix as inter area because it is connected with all area. However, it is having some RLSs too, but it will not install them inside its routing table because intra area is always preferred over inter area. So here you can see that on R3 we are having all prefixes coming as intra area because it is participating in area 0 as well as it is also participating in area 1. If you are having any problem, please let me know. Fine. So this time some RLSs have been generated by this ABR. Great. Let's move on R5 now. R5 is receiving this 111, the loopback of R1. But this loopback of R1 is coming as inter area, and inter area will always come in the form of summary LSA. Show IP OSPF database. So this 111 is coming in the form of summary, and the summary LSA is for area 1 only. Generated by 333. As I said, that summary LSA under link ID it will be having your network ID. Under advertising router it will be having the router ID of advertising router. So who is the advertising router this time? R3. That is why it is having the router ID of R3 under advertising router. But under link ID this is not the router ID of R1. Do not think that this is the router ID of R1. This is the loopback address of R1. Because I am also using router ID as addresses as well. However, it could be beneficial for us to understand this OSPF to use different router IDs. Should I use that? Like 10, 20, 30, 40, should I use that? Router IDs of routers. Okay, forget about it. In next class we will see that. So advertising router is now this. So now you do one thing, open this summary LSS, so IP OSPF database summary for this prefix only. What is it saying? This is what network number, this is network ID, and this is what subnet mask, and this is what metric. But this metric is not from R5. This metric is given by, because this information is given by 333, and you do not have any information about this prefix except that okay, it can reach it via ABR. Now does R5 have this information that where is this 1111 exactly in this network? Hello? Does it have this information? How? अब कहीं भी हो सकता है ना, पता नहीं ABR के उस पार कितने routers हैं. So does it have a complete topological database now? That is why we say that in case of inter area, in case of multi-area OSPF, now your OSPF will become partial link state, not fully link state. Hello? Wow, great. इसको पता है कौन सा राउटर कनेक्टेड है? R1 है, R2 है, कुछ पता है? पहले पता था ना? So this feature is taken from distance vector routing protocol now, because we are relying only on that information which is given by the ABR. This is the metric. It's not it. Previously, in fully linked state routing protocol, in single area OSPF, routers were calculating their cost by themselves. But this time, for their metric, routers are depending on that information which is given by an ABR. So this feature is taken from distance vector routing protocol. Now you do not have complete information, because we know that okay, this information is given by ABR. That's fine. I know very well that who is ABR. Show IP OSPF border But after behind R3, how many routers are there? How are they connected? We don't know anything. And remember, network LSAs 2 cannot move from one area to another area. Let me show you that here on R5 show IP OSPF database, it has generated network LSA itself. This is generated by R5, but this is only for area 1. Remember, network LSA cannot move from one area to another area. Let's move on R1 now. Does it have any network LSA now here?
No.
So it does not have complete information. That's why we say that in case of multi-area OSPF, your OSPF will become partial linked state routing protocol. Have you understood it or not? For sure. Hello. So now on R1 also you can have some inter-area prefixes like the loopback of R4 as well as R5. So this time, what is the cost to reach the loopback of R5? 203. But if you open this LSA show IP OSPF database summary for 55555, so it is showing you that, okay, what is the metric? But here it is showing you how much? 203. So how is it possible? See, this metric is given by R3 ABR. You have to add the cost to reach ABR as well. So this router show IP OSPF border router. See, what is the cost to reach this ABR is 128 plus 75. It will become now Sardeep, are you okay with it? Little bit. Fine. And now I will show you that, let's say, show IP interface brief. My loopback is up. Say show IP OSPF. How many times it have executed SPF algorithm?
4.
Base 1. Base 1. For area 0 it have executed 3 times. For area 1 it have executed 5 times. R4 show IP OSPF. For area, because it is running only area 1, so it have executed only. On R5 show IP OSPF, it have executed only 2 times for area 1. Now on R5 show IP OSPF database, you are having some real SS for 1111, is not it? Now you do one thing, move again on R1, shut it down. So it will run SPF algorithm for area 0. Previously it executed only 4 times, but this time it will be 5 times. And it will remove it from its area 0, right? And then you move on R2. Do you have 1111 available here? No. Show IP OSPF. Previously it executed how many times? 3 times, but now it is 4 times. Then move on R3 also. Show IP route. Do you have that 1111 available here? No. Show IP OSPF. Previously for area 0 it executed how many times? 3 times, but this time 4 times. But for area 1 previously it was having only 5 times, and now also it is having only 5 times. There is no effect on area 1. Even you can move on R4 as well. Previously 2 times, and now also it must be 2 times. Even you can move on R5 as well. Previously it was 2 times, and now also it must be 2 times. And now if you check its database table, show IP OSPF database, you will not get that some DLS actually, because this time ABR will not generate that some DLSA. Hello? Because R3 ABR have not installed that 11111 inside its own routing table. So if your ABR does not have any route in its routing table, then it will never generate some RLSA for that specific prefix. Understood or not? Great. Fine. Let's go for next topic. So this is that how multi-area OSPF is helpful for us just to reduce CPU utilization. But the problem is that now it is not fully link state. It is also, I mean, it have become now as partial link state routing protocol. Fine. The default AD value for OSPF is what? 110. You can also change it, right? Fine. Now let's talk about area types. Here, by default it is point to point. Let me show you. Show IP OSPF interface serial 1/0. On serial interfaces, by default your network type is what?
Point to point.
It means on R2 also it is point to point. If you want to configure IP OSPF network type is what? Broadcast here. You can configure it. Even neighborship will come up, don't worry. Neighborship will come up because timers are same, and for OSPF it is not written anywhere that okay network type must match. Only timers must match, and in case of point to point and broadcast timers will match. Timers are same. It will simply wait to configure itself as a DR because network type is broadcast. Neighbor is not participating in DR BDR election because network type is what? Point to point at the end of R2. That is why this time R2 is not participating in DR and BDR election. That is why R1 will become now DR and it will form neighborship with R2. Don't worry about that. Access start will move into exchange state and finally it will move into full state. So it has configured itself as a DR, and once after configuring DR, neighborship came up into full state. Now show IP route. Does it have any route available here? But neighborship will remain there. So it can happen in case if in a single segment if you have configured your network type as point to point on one end and broadcast on another end. So make sure that in this case your network type must match on both ends. So move on R2 now. On it says 1/0 also I'm going to configure IP OSPF network type is what? Broadcast. This time they will perform DR and BDR election so that they will form neighborship because R1 was already elected as DR. And now R2 have immediately elected as a BDR, and now it has formed a neighborship with R2. Show IP route, all routes must be there. And now inside the database of area 0 itself you must have that network LSA because now DR and BDR election is there. Yeah. So remember, it is not true to say that if your interface is serial interface, DR BDR election will not be there. It will be depending on network type of OSPF, not interface type. Have you understood it now? Like in this case, they are electing DR and BDR in between R4 and R5. R4 and R5, right? Now you do one thing because we know very well that we are having only two routers on this Ethernet segment. So it is always better idea to configure its network type as point to point. Otherwise, convergence time will be higher. Are you getting my point or not? So it is always recommended, it is always good to configure your network type as point to point even over Ethernet links too, if you are having only two routers available in that Ethernet segment. Hello?
Yes, sir.
Are you okay with it?
Yes.
So remember that you must be having only two routers in the Ethernet segment. If you are having more than two routers in a single Ethernet segment, then you must not configure its network type as point to point. In a multi-access network, if you are having only two routers, configure point to point. And in a multi-access network, if you are having more than two routers, then never configure network type as point to point. Otherwise, there can be a big problem. Even we can prove it. Like this time, first of all, let me do one thing. By default, its network type is broadcast onto Ethernet. I'm going to configure their priority as 0 so that no one will be eligible to become DR. So we will see that their neighborship will stuck in two-way state now. Because in between two DR others, because now if you configure their priority as 0, it means they will never be eligible to participate in DR and BDR election. So that both ends will become DR other now. See, if Ethernet port with the network type broadcast is not either DR or BDR, it means it will be DR other. And in between DR others, in between two DR others, neighborship will never be formed. Neighborship will stuck in two-way state. You do one thing, move on R4. IP OSPF priority 0. On R5 also, interface FA0/0 IP OSPF priority 0. Show IP OSPF neighbor. Just wait for a moment. See, they have moved actually into two-way state now immediately. But if you configure priority as one only on one end, then they can form neighborship. Their adjacency can move into full state time. Hello.
Yeah.
Understood or not?
Yes. Sir, can you show static neighborship?
What?
Static neighborship.
I will do everything, don't worry. But I can't perform everything together. I will not skip any single topic.
What will be the command?
Don't worry. It will be covered now in next class. Fine. So the others neighborship has stuck in two-way state. You do one thing now. Go to R5 FA 0 by 0 and configure IP OSPF. Network type is what? Point to point. In same manner, move on R4. This time there will not be any problem, right? Because in case it's their priority, because in case of point to point, your default priority is also 0. So there will not be any problem anymore, even after configuring priority as 0. Show IP OSPF neighbor. See, R4 is having neighborship with R5. If you move on R5, R5 is also having neighborship with R4. And there is no transit network now in the router LSA of R5 and also in the router LSA of R4. Show IP OSPF database router 5.5.5. There is no transit. Now it will be stub network. See, because this time they do not have DR and BDR redirection onto this subnet. So I hope that now you have understood the difference in between stub and transit as well. Wherever you will find transit, it means it is having some neighbors onto this network and it is also having DR and BDR over there. If it is stub, it means it's a stub network and a network. Might be it is having neighbor but only point to point neighbor. But for point to point neighbor, it will be having a different entry. Have you understood it or not?
Yes.
So wherever you will be having transit network inside router LSA, it means it is having DR BDR over there. Even like you can move on R2 and then you can open router LSA generated by 11111. This time you must have transit network, you see, because this time you configure their network type as broadcast in between R1 and R2. Fine.
Okay, so that's the end of today's video. So I hope you learned something new today. We'll be coming with few more videos of OSPF, guys. See you later. Thank you.